Andreas, I am so excited to have this conversation with you here at the Davos Imagination and Action Summit. So, I've noticed there's so many conversations going on about AI. And, what I've noticed is like a lot of conversations about, of course, the amazing potential for AI, but also the risks to humanity. And what I love about our, shared interest is we're both thinking about what are ways that our understanding of the human brain can create a better future.
Yeah, no, yeah, it was great meeting you, and I'm very excited to be here too. Yeah, that's absolutely the case that AI is probably the most amazing human revolution that will be experiencing in the next few years. And what I'm particularly excited is how we can build AI that is going to serve humanity for the benefit of humanity. And right now, all the major labs are putting all their bet in one approach, which is what we can call the behavioral alignment, right? We're collecting huge amounts of human data. We spent 4,000 years as humans writing text, and AI has basically ingested all these behavioral uh, human behavior into a neural network, and it's mimicking intelligence. And it's doing an amazing job, and we have the scaling laws on this. However, we also see that there are some issues with it. For example, it doesn't seem to have common sense the way humans do. It's very easy to break it down. It can be a genius in solving the most complex math problems, but when it comes to, for example, having a robot in a new kitchen like has never seen before, it doesn't seem to be very good. They are learning slower than us, so they do have a lot of limitations. And what I'm particularly very excited is that in the last 10 years, there's been a parallel revolution in AI in neurotechnology. Now we have new technology, especially in the last 3, 4 years, that we can collect what we call the nuclear fuel of intelligence, like neural activity in the brain at the level of individual neurons talking to each other. So we can follow the causal mechanism of intelligence and build AI systems that are more aligned to humans. They will see the world the way we see it, perceive it the way we see it. So this is what I'm very excited about, to build AI that is smarter and safer because it's more aligned to the mechanisms of human intelligence.
Amazing. Yeah. So we had some great conversation last night where we were, talking about this, shared connection in our work. Our work seems in some ways so different, but in some ways it's not. So my interest is in family businesses or specifically family entrepreneurship. And what I'm thinking about is, family businesses create 70% of global GDP. Yet, because of the underlying family dynamic, family businesses do tend to adjust to change more slowly. They actually, according to research, do better typically in environments where there's a slower pace of change, which is obviously not where we are. And family businesses are critical to families, communities, societies. So, what I am thinking about is what are the ways that in the age of AI, family firms, in terms of this is actually the business, can thrive, as well as healthy family relationships and greater personal satisfaction in work. And what I have come to realize by looking both at family systems theory from the psychology, behavioral science side, as well as neuroscience of learning from the brain side, is that core, basic human brain functioning that comes from evolution that keeps us safe, that's critical to our day-to-day activities, at the same time is really what makes it so hard for families to communicate, collaborate, and innovate together. And what I see is an opportunity to use, again, this combination of psychology and neuroscience of learning to create simple processes where family members can learn to actually rewire their brains, use neuroplasticity to rewire their brains so that they can have better automatic reactions, better processes that can facilitate innovation. And with that, I think that, I've noticed that there have been quite a few articles saying that the age of AI is the death knell for family businesses. And I do think there's a risk. That's real. But I also think there's a solution. And the solution is to really get to these core simple processes that family members can use to achieve the outcomes they want. And that will allow family businesses to continue to tap into all of the things that have made them successful, have led to them creating 70% of global GDP, to continue to build on that in the age of AI.
No, that's very exciting because as we were talking last night, one of the issues, if I understood, in small family businesses is that they are sometimes slow in adopting new technologies like AI. And I think there's a fundamental thing here that is related to what I was talking earlier, that we humans understand other humans. Like we have a theory of mind of other humans. We understand, ourselves in the way we understand each other. There's some level of trust in this, right? So if we build AI agents that are very misaligned mechanistically to us humans, then there's a risk that this lack of trust, there won't be as trust worthy, and there is a safety risk potentially. So I think it will be exciting, at least from my angle, is like we can build AI that humans they perceive the world the way humans do, then even it will be easier to get deployed, particularly in like in family businesses, small or big, where trust seems to be maybe a very important value. And that's how they get created, if I understand correct.
Yeah, no, that was such a great insight from our conversation that actually your work might benefit family businesses. I would have honestly never thought that before we started this conversation. One thing actually I would love to understand more about your work is how are you going about mapping human intelligence? How do we do that?
Yeah, so that's a great question. So the human brain consists of 100 billion neurons, and it has about 100 trillion connections. So basically each neuron like talks to about thousands of others and gets input from thousands of others. So you can imagine a society of 100 billion people talking to each other, but talking in a very special way, not like pairwise, but let's say in these thousands of interactions at the level of individual neurons. So that's how you get 100 trillion connections. So what we're not using like MRI or EG or more global technologies, because we're trying to understand the language of intelligence. And neurons communicate with each other with something called action potentials. They're like sending these blips to each other. Literally, they're silent and then they go blip, 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 and other neurons listen. So we are using a technology where it's these very thin probes. They're built in Belgium by IMEG, one of the most of the advanced research foundries in the world. And we insert them, they're like thinner than a hair, and we insert them very carefully inside the brain. And while there is a cognitive tasks that are engaged, then we extract that intelligence, like the activity of the brain, the thought process itself, when, for example, someone is solving a puzzle or is, trying to like make a decision in the world, watching a movie and stuff like that.
Yeah, so that is fascinating. And one of the things you explained to me is that the level that I am working with, the neuroscience that's available today,
Yeah.
right, has a very high level kind of understanding. And you're really building that deeper understanding.
Yeah, yeah, exactly. Yeah, we're trying to go. I mean, you're studying the brain at the behavioral level, like looking at the interactions between humans. We're trying to understand it mechanistically. What's the causal relationship between human behavior and the activity and the computations, the algorithms that are happening inside the brain?
Yes. So I right now what I'm looking at is the sort of system one versus system two
Yes.
brain functioning, and how system one, which is really our automatic reactions that I was surprised to learn this. I didn't know before I studied it. 90%, 85, 90% of our activity are automatic reactions. And of course, that's what keeps us safe.
Yeah.
It's a critical evolutionary element that we need to keep. It also preserves our brain functioning for our system two brain, which is the creativity and innovation and problem solving. And what I've learned from mapping that into family systems theory is that when it comes to working with family, the reason why it's so particularly difficult is that our combination of our emotional connection to family, which can be positive or negative, that can actually trigger our flight or fight response. At the same time, families tend towards homeostasis, or keeping things the same, because that actually it protects the family. It can protect from conflict. It can protect from difficulties, and so that this combination of these two things really leads to, when you're working with family, a dynamic where it can be hard to get to that kind of system two brain when you need it. And so, yeah, I'm actually curious to hear your feedback about that. But my approach is that families, or individuals in families, can solve this problem through neuroplasticity, but actually through just retraining their brain so that they can adjust some of their automatic reactions to be the ones that they really need to achieve their goals.
Yeah. No, that's fascinating. Yeah. So our brain, for example, about in primates, between 30 and 50% of primate brains are involved in processing visual information. Vision is very important because we have to survive. Like if you are, that right now we're looking at each other, we're interacting, social interactions. If you are out in the savannah and you're a primate, you have to mate, you have to avoid dangers. And those systems have evolved, we're all like visual geniuses. We don't have time to be thinking about it, right? It has to be automatic. And the same with motor control, right? So and in some ways, AI and someone Moravec and others predicted, like in the 80s, it's called Moravec's paradox, that things that are typical for us humans, like for example solving math problems, playing games like chess, Go, you know, writing maybe, it'll be easier to be solved by AI versus these more innate like system one systems that are more evolutionary old but also very important for survival. And this is related to the fact that we have these instincts, to survive, and that's why it is, But it doesn't mean that those system one things are simpler. If anything, they're more difficult computationally, and they're so important for evolution that maybe it's harder to override them. And you're right. Like as we understand more about the brain and learning, we still do not there's so much we know very little about systems level analysis of learning. Right now, we're forming memories, we're like interacting. How does the brain change exactly? We don't know. But with these new technologies, the hope is that we'll be able to understand learning also at the mechanistic level.
Yeah, so I'm looking forward to learning more about your work as it progresses, because I can see how um, more information about exactly how these brain processes work, system one and system two, and about how the learning process works is going to be so important for families who are having difficulty. A lot of times, families, when they tell me about their challenges working together, and what I find is that families often think their challenges are unique, and they're embarrassed about them. They don't want to share them publicly because they feel that it reflects badly on them and their family. But my observation is that actually every family has those problems, and I don't say that to diminish anyone's challenges, but more to normalize it, and for families to begin to understand that this is really just how our brains work, and they can learn a few simple and I say simple to say, difficult to do,
Yeah.
but it is possible to focus on these clear and simple practices that can help to be able to like I said, generate these new automatic reactions when we're in that conversation with a family member, where we want our initial reaction might be to back away because we feel hurt or frustrated, or to get angry, or to just agree because we don't want to upset. None of those are the foundations for curiosity and innovation. So that's, but I can see how there will be so much more knowledge coming out about how that works.
Yeah, no, I agree. And, we are, part of trying to understand the brain is exactly what you are saying. We're trying to understand not just like our sensory, the way we perceive the world, we act in the world, but also our more social interactions, our innate, how is trust, love, feelings encoded in the brain, how stimuli interfere with this. So it's a very systems approach to the complexity of understanding human behavior that now with new technology we'll be able to do this at scale. Until now in neuroscience, from a mechanistic point of view, most of the work was specialized in individual labs studying certain parts of the brain under very specific conditions. But we humans and animals evolved to interact in a very complex world, and we need and the entire brain is involved most of the time, the way we behave. So we need to study the entire brain at high resolution during the complexity of the natural world, and that includes like social interactions, and of course between family. Eventually, we have to study at different levels of society.
Andreas, tell me a bit more about your vision for the future. What do you hope will be the outcome of your work?
Yeah, that's a great question. One vision for the future is to create AI that's going to help society. For example, like you can think like one example is like if we could build robots that are aligned to us, that will, be cooperating with humans. They'll be anthropoid in the in the sense that they will be built physically to interact with us. Then you could see, like for example, the developing countries, the developing world, where there are issues with farming, with housing. You could like help, develop a better future. So it could be huge economic impact to sort of elevate not just the richest people in the richest country, but the entire world. So that's kind of one thing that I'm particularly excited is to build, something that can democratize AI and deploy it in a way that will benefit, the entire planet.
That is
Yeah.
amazing. And, that actually, again, connects to my work because one of the things that I have observed is that, according to research, 65% of businesses in the world, not 65% of family businesses, 65% of all businesses in the world are micro family businesses. And those are businesses that, may not have access to a family business consultant or to a family business executive education program, yet they're critical forces for their family, their community, and they may be, providing, essential both economic and social resources to the families involved. So it's fascinating to hear how your work might actually elevate the capacity of those families. Part of what I hope will be an outcome of my work is, similarly democratizing access to knowledge about how families can pass their capacity for value creation in their business, value creation in healthy family relationships, and value creation in terms of individual satisfaction. How can we democratize that capacity for families to pass that on, to develop and to build that? And I hope that I'm sure that AI will be an important process of that, not, partly what you're talking about, also in terms of, you know, access to educational resources in new ways.
No, one of the things that related to your question is that, I'm very excited, of course, of this digital AI, right? And we all use it all the time. And, I do research at Stanford. I'm a professor there. We use this as a tool. But also, I worry about, especially the younger kids, they're sort of like living almost in this digital world and they're not experiencing the physical world, which is what we humans evolved to do. And that's where we should be experienced. So, and I think to do that, to bring AI into the physical world, I mean, that's what we call robotics. But I think to do it there in a safe way, we need to like have a new revolution in AI. I think the current approach may not get us there. And this is where I think getting information from the brain and building AI that is more neurally aligned with the brain will get us there. And of course, this will impact society broadly, including what you're interested, like businesses at different levels, like family, centralized businesses and other.
Yeah. So another, hope is just as you were saying, we have an age of disconnection, of loneliness, disconnection from family. There's a trend, at least in the U.S., of in some cases young people estranging themselves intentionally from their family. And part of my hope is that providing easy access to these resources about how families can collaborate, communicate more effectively, can help to strengthen those family bonds, because it's a core foundation of our society in terms of emotional support, in terms of connectivity, and in terms of perhaps reducing this feeling of disconnection. But actually, one question I have to ask is, I guess my initial reaction when you explained your work was, oh my gosh, if AI is going to be able to be modeled after our human brains, then maybe that, pushes humans even further out of the range of our participation in work and in society. So how do you think that will play
Yeah,
out?
I think of it a little bit the opposite way. I feel like it's, AI is capable of consuming way more energy than we can. It can read the entire, all human knowledge. So obviously, it's going to become super intelligent sooner or later, right? And I think the danger of like creating a very alien form of AI that sees the world, understands the world in a very different way than us, can be very dangerous for humanity long term, right? So it's kind of like an evolutionary path that if we start with AI that is more aligned at this mechanistic level to us, it has the same grounding as us, the way it perceives the world, not only will be able to trust it better, but it will evolve into an AI that will more has a higher chance of like helping humanity versus like competing with humanity. So I do think there is an argument there why building AI systems that utilize the more human and animals, it's not just humans, animals are very similar to us too, are aligned at this mechanistic level, would be a better form of AI in many ways.
That's fascinating. And do you think that as you've developed your approach, your processes, your research, how will that uh, be implemented and as being the new model of AI? Will there need to be policy, or how do you envision that
I
happening?
mean, first of all, right now, we need, we and others, we're launching startups to try and scale these approaches. But ultimately, yeah, I think governments, are gonna try and at the level of not just individual governments, but at the world level, trying to like regulate, these intelligent systems, these intelligent agents. There will be issues, even ethical issues, like what rights may they have as they get smarter and smarter. They're more humanoid-like. The way that we perceive them, they perceive us. So I think it needs a greater discussion and conversation with society, with politicians, with people, philosophers, psychologists, to bring them to play, not just like scientists and engineers. At least that's my whole.
Well, this has been like such a fascinating and amazing conversation, and I look forward to staying in touch with your work
Me too.
and seeing how it can
Yeah.
help entrepreneurial families around the world.
Thank you very much.